Bright QT. Every student matters.
Equal chords of a circle or two congruent circles are equidistant from the center or centers. So if I consider only one circle and two chords of the same circle, these are equal chords. So AB and CD are equal, right? This AB is equal to CD. Now I need to see whether these are equidistant from the center or not. So if this is center and this is distance OM and this is distance ON. How do we measure the distance of a point from a line? By dropping a perpendicular from that point to that line. So that is why I have taken these angles as 90 degrees. Now I need to see whether OM is equal to ON or not, right? So the first thing that I am going to use here, that a perpendicular from the center of a circle to a chord of the circle bisects the chord, right? So I can say this portion here AM is equal to BM and this portion here CN is equal to ND, right? Because these are perpendiculars drawn from the center to these chords, and we know AB is equal to CD because these are equal chords, so their halves will also be equal. So I can say AM is equal to CN, right? This much is clear. Now consider these two triangles, this triangle and this triangle. In triangle OAM and triangle OCN, what can I say about OA and OC? These are equal because these are radii of the same circle, right? What can I say about AM and CN? These are equal. I have just shown you here half of the equal chords, right? I have shown you two sides equal. Now look at this angle. This angle is 90 degrees, this angle is 90 degrees. So in triangle OAM, angle OMA is equal to angle ONC, right? Both equal 90 degrees, right? So by right angle hypotenuse side congruence criterion, I can say triangle OAM is congruent to triangle OCN, okay? And by CPCT, what can you say? That OM, this distance, is equal to this distance here. OM is equal to CN. OM is equal to ON by CPCT. Hence we can say that equal chords of a circle are equidistant from the center. Now if you take two congruent circles, it will be no different, right? Same applies to that case also. Let us say these two are congruent circles, right? And these two are equal chords. AB is equal to CD. So this chord is equal to this chord, and these radii are already given as equal because these are congruent circles. So the radii are R each, okay? Now what you can do is you can prove that these two triangles are congruent, or you can in the same manner you can drop a perpendicular here and drop another perpendicular here, OM and ON. Rest of these steps will be same like this, okay? Because in these two triangles also it is given that AB is equal to CD, so their halves will also be equal. So this portion will be equal to this portion and this is equal to this. These angles are 90 degrees each, so by RHS congruency these two triangles will be congruent, hence the results will follow like the above case, right? Chords equidistant from the center of circle are equal in length. So yes, this is also true. and for this also you need the knowledge of triangles. Let us say this is one chord, this is another chord, and these are equidistant from the center. That means this distance OM is equal to the distance ON. Okay, so this is given as equal to this. And now we need to see whether AB is equal to CD or not, right? So again we will consider those triangles. Let us say this is one triangle, this is another triangle. So in triangle OAM and OCN, you can see OA is equal to OC, right, because these are radii, and OM is equal to ON. It is equidistant, so it is given. In this case we are taking it as given, and we will show that AB will be equal to CD. So let us take it as given fact, and then we need to show that AB is equal to CD. Then we will be able to prove this theorem, right? So I have said that this is equal to this side is equal to this side, because these are given, and these angles are 90 degrees each. So if I can call it angle M, so angle M is equal to angle N equals 90 degrees, right? Hence triangle OAM is congruent to triangle OCN, okay, by RHS congruence. Now by CPCT I can say that AM is equal to CN, right? If I know that AM is equal to CN, then double of AM will be equal to double of CN. And what is double of AM? Double of AM is AB. Why? Because OM is perpendicular to chord AB, hence it bisects AB. Hence I can say AM is half of AB, right? So if AM is equal to CN, then double of AM, that is AB, will be equal to double of CN, that is chord CD, because of the same reason. Because ON is perpendicular to chord CD, hence it bisects chord CD. CN is half of CD. So AB is equal to CD. Hence this theorem is proved that chords equidistant from the center of a circle are equal in length. Okay.